Hello, myself Susobhan, Assistant Professor of SVIST in ECE department. Today I am going to discuss the applications of PN junction diode. So, PN junction diodes are basically used in different kind of circuits. For example, as a rectifier circuits, there are several kind of rectifier circuit should be used by using PN junction diode. It may be half wave rectifier, it may be full wave rectifier, and it is also used as a clipper and clamper circuit, etc. So now today I am going to discuss the applications of PN junction diode as a rectifier circuit as well as clipper and clamper circuits. So PN junction diode is basically a unidirectional device. That means the current will always passing from P to N side. No current will pass from N to P side. This is called basically the blocking state. So rectifier circuit are classified into two types. One is half wave, another one is full wave rectifier. And full wave rectifier circuits are also categorized into two types. One is center tapped full wave rectifier, another one is bridge rectifier. So half wave rectifier. Half wave is defined as a type of rectifier that only allow one half cycle of an alternating input voltage or AC voltage and blocking the other half cycle. And this kind of rectifier are basically used to convert alternating voltage to DC voltage. So for the constructions of half wave rectifier circuit, we should use only one diode in a circuit. So this is the circuit diagram of a half wave rectifier. Here you can see here we are used only one diode, which is D, and load resistance, which is RL, and we are applying some alternating signal or AC wave across the input terminal, which is basically called the V-in terminal, and we are getting the output DC across the load terminal. This is the entire waveform of input and output signals. So when we apply a positive polarity towards the diode, when the entire signal will passing, then two kind of phenomena will be occurred. One is the diode is in conducting state, that means the forward biased condition. Another one is the diode is in blocking state, that means the reverse biased conditions. So it will be happened how it will be happen. Let's see, here we are applying a sinusoidal waveform, which is already seen in this figure, in this diagram. So we are considering two peaks. The upper portion of this zero line or the horizontal line, the upper portion of the peak is called the positive peak, and below the zero line the peak is called the negative peak. So during the positive half cycle of the input voltage, the polarity across the diode will be like that. The P terminal will be positive and respectively the lower terminal will be negative. That means the diode is in conducting state, so current will passing through the diode, and therefore we are getting IL, which is called basically the load current across the resistor RL. Okay, so since a forward biased diode offers a very low resistance and the voltage drop across the diode, which is also very small, for germanium it will be 0.3 and for silicon it will be 0.7 volt. Okay, So this is basically called the cut-in voltage for germanium as well as silicon. So here in this wave waveform we can see V in the applied input voltage, which is the sinusoidal signal, and V out is the output voltage across the diode towards the load terminal. So when the positive peak, the entire cycle durations or one cycle will be completed within the range 0 to 2 pi. So that means 0 to pi is half wave and 0 to 2 pi means the entire cycle, the full wave cycle. So when the positive peak, that means 0 to pi duration peak, will passing across the diode is in conducting state because the polarity of the upper side is positive and the lower side will be negative. So in that case we are getting output voltage, and this is denoted over here V out from 0 to pi range. But when the polarity has been changed, when the negative polarity will come, suppose in this diagram pi to 2 pi, I am considering pi to 2 pi region. In that case the upper side of the circuit will be change its polarity, that means it will be negative, and the lower side will be positive. That means the P terminal is negative and the N terminal will be positive. So such kind of configuration is basically called the reverse biased configuration. That means the diode will be in blocking state. So across the output terminal we are not getting any current. So when the negative peak will pass, the output voltage will be 0. That means we are not getting any output voltage, so there will be no harm. Again, when the positive half cycle will come, suppose in this diagram 2 pi to 3 pi range, then the diode will again in its conducting state, and this entire procedure will happening randomly. So now this is the basic operations which I have told already. During the positive half cycle of the input signal, the diode is in forward biased, and the negative half cycle of the input signal, the diode is in blocking state or reverse biased mode. Now I am going to the full wave rectifier circuit. Why? Because in case of half wave rectifier we have already seen we are not using two half cycle at a time, because here we have used only one diode. So to recover this problem we have to use full wave configurations. So rectifier that utilized both positive and negative half of the input cycle and undergoes rectification is defined as a full wave rectifier. It requires two or more diodes. In case of center tap configurations we have to require 2 diodes, but in case of bridge configurations we have to require 4 diodes. So this is the configurations of center tapped full wave rectifier. Here you can see we are using 2 diodes, one is D1, another one is D2. This is the transformer. Basically we have to use in rectification purpose, and this one is the primary winding of the transformer where we should apply the AC voltage, and this one is the secondary winding of the transformer from where the signal, the output signal, suppose this is a step down transformer because this is the DC circuit, so the output step down voltage will be passing through diode D1 and D2, and RL is nothing but it is called the load resistance, from where we are able to find out the output voltage. So when the positive peak, center tap transformer is a normal transformer that has a slight modifications in it, and its secondary winding has a wire connected at the center. Why it is called center tap? Because if we see the configurations, we can see the load resistance will be connected from the center terminal of the secondary winding through a wire. The input AC supply, while passing through the secondary winding, its voltage is divided into two halves. Same phenomena that was already happened, or we could see in case of half wave rectifications. Same phenomena is repeating over here. Two kind of peak, one is positive half and another one is negative half cycle of the signal. So this is the entire output waveform of full wave rectifier. From this waveform we can see this is the input signal, sinusoidal wave, and Vm is the maximum peak of the signal respect to time or frequency. So 0 to pi duration range, what will be happen when the positive peak, entire positive peak, or the half cycle, one half cycle will passing through the diode, what will be happen? The upper portion is positive, lower portion will be negative, and alternatively these portions will be positive and this one is the negative. That means the time the diode D1 is in on state, because P side or P terminal is positive as compared to N terminal. So current will flow through D1, but no current will flow at that moment through diode D2. That means D1 is in on state and D2 is in blocking state. Okay, so in case of negative half, what will be happen? The alternating phenomena will be happen. That means at that time duration, that is pi to 2 pi in this diagram, the diode D1 will be in off state or blocking state, because the polarity is now, in case of D1, is negative polarity which is applied across the P terminal, and the polarity of D2 will be positive because the cycle duration is changed. Okay, the half wave duration, the half wave cycle duration has been changed. So that means the P terminal of the diode D2 will be positive, more positive as compared to diode D1. Hence the current will passing through diode D2. So we are getting some output across the diode, and this is the total output respect to this input Vin. Here we get at positive half cycle, during the positive half cycle diode D1 is in conducting state, and at negative half cycle diode D2 is in conducting state, and same phenomena will repeat respect to time or frequency. Now I am going to the bridge rectifier. So here we are connecting basically 4 diodes instead of 2, which are basically diode D1, D2, D3 and D4. Okay, same output waveform will be produced by full wave rectifier circuit. So this kind of configurations by using 4 individual rectifying diodes basically form a closed loop, and this is basically called a bridge configuration. So during the positive half cycle, when the input positive peak of the input voltage will be passing through the circuit, what will be happen? The current will pass through diode D1, then load resistance, then it will pass through diode D2, take a path, and then it will come to the negative side of the polarity. That means when the positive half cycle will pass, then diode D1 and diode D2 will be in conducting state, and they are operated in series, and diode D3 at the same time, diode D3 and D4 both are in reverse biased. That means no current will pass through diode D3 and D4, because we already seen that diode is basically a unidirectional device. That means current will pass always from P to N side. So in case of negative half cycle, the alternating phenomena will be happen. That means diode D3 and D4 now will be in series connection, hence the current will flow through diode D3 and D4, but diode D1 and D2 will be in reverse mode. So this is the entire output waveform. Here we can see each half cycle has been shared by two diodes at a time. So when the positive peak from 0 to pi durations will passing, in that case diode D1 and D2, diode D1 and D2 is in conducting state. Whenever the negative half cycle will passing, D3 and D4, these two diodes will be in conducting state, and same phenomena will repeated again and again. And this is the total output current across the AC input. Now I am going to discuss another applications of diodes, which are basically clamper and clipper circuit. Clamper is an electronic circuit that changes the DC level of a signal to the desired level without changing the shape of the applied signal. Okay, the circuit moves the whole signal up and down. When the whole signal will move upward directions, then this kind of clamping is basically called the positive clamping, and when it will move towards downward directions, it will be called the negative clamping. So that is why these are basically classified into two types. One is positive clamper, another one is negative clamper. So this is the circuit diagram of a positive clamper. Here you can see we are use a capacitor, okay, so a positive clamper circuit. A clamper circuit adds the positive DC components. When the clamper circuit adds the positive DC components, then the input signal to push it to the positive side, that means above the zero reference line. So here in this case we can see the input waveform, the entire durations from Vm to minus Vm, but after using the clamper circuit, okay, the output waveform has been shifted from 0 to 2 Vm. So how does it happen? Basically, in case of when the negative half cycle, as I considered, when the negative when the diode is in basically on state, when the negative half cycle will be passed through the diode, that means in case of negative half cycle, we can get the upper portion will be negative and the lower portions will be positive. That means the diode is in conducting state and the capacitor will be charging through this path, hence we will get output current. But in case of positive half cycle, no current will pass because the diode is in reverse biased mode. Okay, reverse biased mode. So when the negative peak is passing across the diode, in that case the diode is in conducting state, that means the capacitor is in full charging condition. So the capacitor voltage Vc equal to nothing but it is minus Vm, which is the maximum peak voltage of the signal. So now in second case, which is basically the open circuit case, that means the diode is in non-conducting state, which is basically the third cycle or the positive peak considerations. So in that case what will be happen? If we apply a loop equations, so we are get that the Vi minus Vc minus V0 equal to 0. That means output voltage is nothing but it is equal to Vi minus Vc, input voltage minus the capacitor voltage. So now we already seen that the capacitor voltage is nothing but it is the maximum peak voltage in negative directions, which is minus Vm. So if we put the value, then obviously we will get V0 equal to Vi minus Vm minus plus, that means Vi plus Vm. So when input voltage is equal to 0, in that case, if Vi equal to 0, in that case output V0 is equal to Vm, which have been shown over here. But when input voltage is equal to Vm, in that case the output will be 2 Vm, which is shown over here in this diagram. That means it will be shifted to plus Vm from Vm. Okay, from Vm to plus Vm. That means the entire durations will be 2 Vm. So now in third case, when the input voltage is equal to 0, then again it will be moving downwards directions and it will intersect the Vm line again. So now the last case, when Vi equal to minus Vm, the output will be touching the 0 line. That means output equal to 0. So from these configurations or from the operations of the circuit, you can say in case of positive clamper, the DC component will be shifted upward directions. Same phenomena will be happen in case of negative clipper. Here the directions of the diode just has been changed. That means it will be operated in the positive during the positive half cycle durations. In negative half cycle durations, it will be in blocking state. So here in this case, Vi plus Vc, V0 is equal to Vi minus Vm. So that is why it will be shifted towards the minus line up to minus 2 Vm point. Okay, this is nothing but this is just the reverse of the positive clamper circuit. That is why it is called the negative clamper circuit. Why it is called negative? Because the entire DC signal is shifted towards the downward directions or below the 0 line. Okay, so that is what is called the negative clamper circuit. Now I am going to discuss clipper circuits. Clipper circuit is a circuit that rejects the part of the input wave while allowing the remaining portion. The portions of the wave above or below, above means above the 0 level and below means just downward directions from the 0 level. The cutoff voltage determined is clipped off or cut off. There are two kinds of clipper circuit has been shown, like clamper, which are basically positive and negative clipper circuit. So this is the diagram of a positive clipper circuit. So now in case of positive clipper means it is a clipper circuit that is intended to attenuate the positive portions of the input signal. That means when we are applying a sinusoidal signal across the diode, this is the configurations of a positive clipper circuit. Then you can get when we are basically applying positive. So now when we apply a sinusoidal signal across the diode, so then obviously you can get during the positive half cycle from 0 to Vm, the maximum peak durations. 0 to Vm is the maximum peak. So during the positive half cycle, the upper portion is positive and the lower portion will be negative. That means the diode, the N terminal of the diode will connect it to the positive polarity of the positive polarity of the external signal voltage, and a P terminal is connected to the negative polarity. So that means the diode is in blocking state or reverse mode state or non-conducting state. So no current will passing. That means it is basically an open circuit condition. That means no current will passing across the load terminal. So no current will passing across the. So output voltage is almost equal to 0, which is shown over here. Across the positive peak, we are getting some amount of voltage, and which is very lesser. Okay, that is why it is theoretically we are assuming that the output voltage is 0 when the diode is in open circuit condition. But when the polarity has been shifted or changed, that means when the negative polarity will come, in that case the P side of the diode will be connected to the positive polarity or much more positive value as compared to the N side. or you can say the diode is in short circuit condition or the forward mode condition. So in that case the output voltage V0 is nothing but it is the replica of the input voltage. That means V0 is equal to V in. So in that case, which have been shown over here, when the input signal polarity is negative, in that case the output, in that case we are getting output voltage which is minus Vm. That means the same replica will repeat over here. That means we can conclude that in case of positive clipper, the positive peak will be attenuated, but due to the blocking state or off state or the short circuit state of the diode, sorry, open state, not short circuit, it is open state of the diode. But in case of negative half cycle, the diode is in short circuit condition, so current will passing through the diode, so then we will get some output value which is minus Vm across the negative peak. So that is why this kind of configuration is basically called positive clipper circuit. So in case of negative clipper, we are just clipped off the negative peak which have been shown over here in this diagram. So how does it happen? The directions of the diode has been changed, nothing else. The direction of the diode has been changed as compared to the positive clipper circuit. So when the positive half cycle will passing, in that case the diode is in on state, so that means short circuit condition. In that case output voltage will copy the input voltage, so we will get some output value above zero level, that means the positive half cycle durations. Okay, so that is how we are getting the output voltage plus Vm, but minus Vm, but we are not getting any output, when the polarity has been shifted from positive to negative, that means the input voltage polarity is negative, so diode is in blocking state. Okay, because the P terminal is connected to the negative and N terminal will be connected to the positive, so diode is in reverse mode. That means the entire circuit will be in open circuit condition, so output voltage will be 0. So that is why the negative peak will be clipped off. Okay, so this kind of configurations is basically called the negative clipper circuit configurations. So that was my lecture on the applications of PN diode. Thank you.